Welcome and study with Tanzania Institute of Education.
Hello students, warmly welcome in the physics class. I hope that you are fine. I am teacher Jafari, and today I am going to teach you the topic named radioactivity, a Form 4 topic, but it is a good revision for all other higher classes like Form 5 and Form 6. I hope that where you are, you have already prepared each and everything required for this lesson. I insist again, please get prepared the exercise, prepare also a pen, so that we are going to be together in our discussion today. As I mentioned previous, that we are going to see a very important subtopic under this radioactivity, which is the nucleus of an atom. Dear student, have you ever tried to think what all the things which is surrounding us are made up? As a scientist, this is a very interesting question. All the things around us, including you and me, we have been made with materials or some of the things. The question which we have here is going to help us now to know in details these aspects of the nucleus of an atom. I think as a scientist you have already asked that kind of a question. Now have we got the answer? Now please, let us share together here. I have the material here. Every person sees this. This is a matter. This is a substance of which we expect that to verify and see what are the materials which are made this substance. I can try to split up or bracket this as follows. I have broken this material into several particles. Have you seen? But I can also continue to break it into smaller pieces as you see here. I can manage to break it as several aspects as you see to get several kinds and to get small particles from this material. Now, what you have get is that this particle was made up from tin particles. But also, if you try to merge this, or if you try to combine them, these particles, you find that you get also a particle which is very large or great. Do you see? Now, what you can say about is that this particle, which is a matter, is made up by 18 particles. These particles are the one we call the atom. Now, what is the atom? This is the question. Our question here is, what is the atom? What is atom? Dear students, this is not a new question to us. Possibly you have already met it in the chemistry or in other science subjects. But to be familiarized altogether in this period, we all know that the atom is a smallest divisible particle. As you see here, these particles, if you try to break them, they can be smaller and as smaller as possible as you have broken them. So we say that an atom is we say is a smallest divisible particle that can take part in any chemical reaction. That can take part in a chemical reaction. We say they are just smallest depending to the kind of the material. Taking in mind is that, as we said, that all of the things surrounding us, they are termed as a matter. And as we studied the topic of matter, we saw that a matter is having three kinds of the states. That we are having the solid state, we are having the liquid state, but also we are having the gaseous state. But all the states that we are having, whether you are saying about a solid, it is made up with the atom. If you are saying about liquid, they are also made up with atom. But also, if you are saying about the gaseous, they are also made up with the atom. So it depends on the kind of the material you're saying. That's why we say that an atom is a smallest divisible particle that can take part in a chemical reaction. Now, this atom is made up with three subatomic particles. Say that an atom, it is made up with three particles, or sometimes we say the subatomic particles, namely as follows. The first one, we are having the particle which made up an atom is known as the proton. The proton. The second particle or subparticle, is named as the electron. The electron. And the third is named as a neutron. The neutron. Dear student, let us now try to see some of the behaviors or some of the characteristics of each kind of the particle, which are the particles which made the atom. Let us see one after the other. The proton. First one, as we said, was the proton. A proton, first, is a positive particle. It is a positive particle. It is a positive in nature, we say. But furthermore, a proton has a mass of approximately to 1.673 times 10 to the negative 27 kilogram. Has a mass of 1.673 times 10 power negative 27 kilogram. Negative 27 kilogram. This is the mass of this proton. But also, this proton has a charge of a positive. Being a positive in nature, then its charge means it's positive. So it has a charge. The magnitude of the charge is almost positive 1.673 times 10 power negative 27 coulomb. So it has a charge of 673 times 10 power negative 27 coulomb. But this proton is found in the nuclear. So it is found in the nuclear, in the nucleus of an atom. In other name, all of those particles that we are going to, which are found in the nuclear, they are termed as nucleons. So it is one among of the nucleons. So we say it's a nucleons. Nucleons particle. So with these few characteristics of the proton, as we are going, I think we are going to use them. You see, It's a positive. It has a mass indicated here, but it also has a charge. Its charge here is it's supposed to be positive, indicated that it's a positive. Already stated here, it's a positive in nature, so the charge here is a positive, and it's found in the nuclear, and or we call it as a nucleon's particle. The second one we have said is an electron. The electron. Second one, the electron. The electron. Electron is negative in nature. Its nature is negative. So we say electron is negative in nature. It is negative. It is negative in nature. But also, an electron has a mass of 9.1 times 10 power negative 31 kilogram. It has a mass, it has a mass of 9.1 times 10, we say 10 power what? 10 power negative 31. Negative 31 kilogram. You see this mass? The mass of this electron is approximately this. But apart from the mass, if you are finding where it is located in the shell. It is located in the shell or in the orbit. It is found in the shell or orbit. But also, an electron has a charge. The charge of an electron is almost 1.6 times 10 power negative 19 coulomb. It has a charge of 1.6. We have said times 10 power. Good, power negative 19. 1.6 times 10 power negative 19 coulomb. All of this describes what is the electron, which is found in the shell or in an orbit of the nucleus. We are going to see the structure of it as we are going. Lastly, particle we have said is the neutron. The neutron. And this is particle number 3. The neutron has no charge. This is the first characteristic of it, that it has no charge. It has no charge. But if you look in terms of the mass, a neutron has a mass of approximately 1.675 times 10 power negative 27 kilogram. It has a mass of 1.675 times 10, we have said power what? Very good, power negative 27. Power negative 27 kilogram. Where do we find a neutron? A neutron is also found in the nucleus. So it is found in the nucleus. So this also is the second particle, which we call it also as a nucleons. That it is, we call it is a nucleons, or it is nucleons. My student, are you remember how many particles have we found which are nucleons? Good, there are 2. So is a neutron and a what? And a proton. Very good. Now, after looking all this one now, we can now have an idea. That we have tried to... Dear student, as we have seen here, now that the nucleus of an atom is comprised with the 2 main particles. These particles, as we have said, they are the proton and the neutron. So we can now make a summary out that the nucleus of an atom it comprises with the or let us say contain has, we say proton, and neutron. So this proton and a neutron, we call them as a nucleons. So these are nucleons. These are nucleons. Now, as we discussed that a proton is positive in nature, but a neutron has no charge. So we can now make a summary out that a nucleus of an atom is positive in nature. So nucleus of an atom, it is positive in nature. Positive in nature. Again, as we saw, you try to see the mass of proton, the mass of electron, and the mass of neutron. If you compare the mass of proton and the neutron, the sum of it, which are the nucleons, you find that this mass, the mass of the nuclear, is much larger compared to the mass of an electron, which is the one found in the shell. So by that case, we can say that now the mass of an atom is mainly concentrated at the nucleus. So with this, we find that its mass is concentrated at the nucleus. My student, now upon looking all these particles that are made of the atom, let us try to see the important definitions or important items that we found here in this study. We are having an item which we call it as the atomic number. Atomic number. What is it? Atomic number, sometimes we present it symbolically as Z. This can be defined as the total number of protons in the nucleus. Okay, so this is a total number. This is the total number of proton in the nucleus. Now, as we saw that since a proton is in the nucleus, and we define atomic number as the total number of protons in the nucleus, we can say that for an electrical neutral atom, automatically now the proton is going to be equals to electron, or number of protons are going to be equals to number of electrons. So we can have this idea that for a neutral atom, we can say that the number of protons, the number of proton is equal to the number of electrons. We are going to see this important fact. But we're having also another item called as a mass number. Mass number. Sometimes this mass number is noted as A. What is this? We say a mass number now is going to be the total number of protons and neutrons in the nucleus. So this mass number is the total number of protons and the neutrons. Protons and neutrons. Now, how do you find it? You can say that now, if you use it symbolically, we have already know what are protons and the neutrons. And if we denote the neutrons as small letter n and the protons as Z, because we have already determined that these are atomic number, and the mass number is equal to A, we can have this formula that it follows that mass number A is equals to number of protons which is Z plus number of neutrons. So symbolically we can say that A equals to Z plus C. Here we have said if you use small letter n, then it is going to be plus n. This is the very important formula of us, of which if you are asked to know these aspects, you will have to know this formula. Now we have now discussed and look all these particles that are made up with the atom. Let us now try to discuss the mode, or the model, we call it the model of the structure of the atom. Dear students, let us now see the structure of the atom. Structure of the atom. Several scholars made a study upon this, but the remarkable one were the study given by J.J. Thomson, who assumed the atom to be as a sphere, like an orange, of which the electrons were found inside the orange, and the protons were distributed. But these were having some of the weakness. One named Rutherford, a scientific person named Rutherford, came with a model of which we are using it. So the Rutherford model on a structure of the atom, on the structure of the atom relates to the solar system, Dear student, every one of us know the solar system. The solar system is having planets, and its center of it is the sun. So Rutherford takes that structure as we see there, that in the solar system is having the planets which are revolving around the sun in the orbits. So those one is resembled to the structure of an atom in such a way that the nucleus is regarded to the sun, and the electrons which are revolving the nucleus in the shells are the planets, as you see. Now, according to that model, I can also show what we are saying. Look on this. This is the model of the structure of how the structure of the atom is. Dear student, are you seeing it properly? Now, a task now is to identify what do you think is an atom from this model. Now let us have something here. That from our model, to identify the kind of the element here is just to know what are the number of protons. The number of protons is the one which is going to tell us what is the name of that atom. After knowing it, then we have to use a periodic table. All of us, we know a periodic table. The one we studied it in chemistry. The one it is here. Do you see there? Now, let us go together to our model. Our model has how many number of protons? There are how many? Let us count. There are 1, 2, 3. So we are having 3 number of protons in a periodic table. What is the element which is found at the position of 3 in the periodic table? Is what? Very good. Is lithium. Let us write it. That if we write this, the structure of lithium, from our model here. It has how many shells? There are two shells, yes? We are having the first shell, the second shell. So within the nucleus here, we are having two particles. These particles are protons and the neutrons. We counted that how many protons? There are 1, 2, 3. So we are having 3 protons. And how many neutrons? The neutrons are the one being indicated by 0. 0 means is neutral, has no charge. We say that neutron has no charge. So how many are they? They are 1, 2, 3, 4. So 4 neutron. In the first shell, we are having 2 electrons. We normally draw them that this is the first electron, this is the second electron. And in the last shell here, or the second shell, we are having 1 electron. Now, dear student, from this model is the one up to now we are now using it. And we will have several kinds of the questions from this. After looking now the structure of the atom, let us see one aspect or important item here, which is called as the isotope. Before isotopes, let us try to know how now can we write the chemical symbol of the elements. Generally, the chemical symbol, the chemical symbol of an element, is written as A. Let us say here we are having a symbol here, and here let us say Z, where if we define this, we say A is the mass number, and the Z is atomic number. While X is a chemical element, chemical name, chemical element. The chemical element we normally find it from the periodic table, we know. For example, for the elements which we are having here in the model, it implies that the chemical element of our element we identified was lithium. So this can be written as lithium. But how many mass numbers from the periodic table? Lithium has? It has 7. Good. So 7. And what is its atomic number? 3. Very good. Now this is how we normally denote the elements if we were having mass number, atomic number, and it's the name of that particular element. Now isotope. An isotope is a very important aspect in physics. Isotope, we call that these are the atoms which have the same atomic number but different mass numbers. So these are atoms of the same atomic number, but different mass number. Dear student, the isotopes of an element are being obtained due to the different numbers of neutrons in an atom. If you are having a different number of neutrons in an atom, is the main or is the cause of an isotopes. Now, due to this, we have seen that atomic number is a very important aspect of which, if you find in a periodic table, the elements in the periodic table are being placed according to the atomic number. Now, the atomic number, we say that all chemical properties of an atom depends to the atomic number of that particular atom. So here we can have a very important note that the chemical properties of an element depends on the atomic number, to the atomic number. It depends to the atomic number. Atomic number, in bracket we know it's Z. Now if you want to find the charge of an atom, you have now to take the product of Z and the electronic charge. So we can say now that the charge of an atom, the charge of an atom is obtained as Ze, where we say E is an electronic charge, where E is an electronic charge. We all remember, we started this electronic charge E is of magnitude 1.6 times 10 power negative 19 coulomb. So if we were in need to know the charge of a particular element, you will have to be familiarized that you have to take Z times E. Now the isotopes we have said, we are having several kinds. Let us see some of few isotopes we have. Dear students, some examples of isotopes are as shown here. Some examples of isotopes are like, if we can see the isotopes of hydrogen, for example, isotopes of hydrogen. Hydrogen has 3 isotopes, of which named we are having hydrogen 1. This one, if you try to see the number of proton and the number of neutron that we are having here, you can say that here the number of neutron is 0 and the number of proton is 1. We are having 1 and the number of neutron is 0. But we are having hydrogen 2, which is 2, 1 hydrogen, of which if you look to the number of neutron here is going to be 1, and the number of proton, so I mean here is supposed to be, we are having N, and here we can say this is Z, which is the atomic number, sorry, this is Z, and here the Z, which is the atomic number, is equals to 1, remain the same. But we are having hydrogen 3, which is 3, 1 hydrogen, of which if you try to see the number of neutron here is going to be equals to 2, and the number of Z, which is atomic number, is going to be equals, remain the same. So all of these are the isotopes of the hydrogen. But we are having several kinds of the isotopes, of which according to the scientists can have a finding and researches on them. Now why are they making researches on this? Is because isotopes has very many applications in our daily life activities. For example, isotopes are used for the food preservation. If you want to preserve food and so forth, if you take the cobalt, is an element whose its isotopes can use to preserve foods. But and so many kinds of the applications in today's life's activities. But these isotopes has also some negative effects. A good example of the negative effects of these isotopes is as we can see in our animation there. It causes the destruction of the environment, as we saw in the picture. That picture was upon the effects of the use of the hydrogen isotopes in Japan. I think everyone you know what if you say about the cities Hiroshima and Nagasaki, the bombs used to prepare that kind was due to the isotopes of the hydrogen. Now, upon reaching here, let us have one example to see how far are we for the discussions that we have made. I'm going to pose to you one example. Example. You might be given a question that asking you that one isotope of chlorine, we know its symbol is a Cl, is denoted as chlorine with the, what's the atomic number of the chlorine in the periodic table? Good, 17. It's 17. And its mass, 37. The atom being given for chlorine is of isotope with mass of 37. Now the question here, which we are having here, this is chlorine, Cl, capital C, and a small l. Then the question is calculate the number of neutrons and the charge of that atom. Calculate the number of neutron and the charge of the charge of this atom. Now, in our equation here, if you analyze the data, we are given the atomic number, which is 17, and this is noted as Z, but we are also provided the mass number, which we denote it as A, which is 37. Now, using a formula of every one of us, remember the formula, we can now calculate what is the number of neutron. This can be written as, first, you write the data provided. We are given, can write here that given, we say mass number, which is A, equals to 37. In fact, all of these, they are in grams because they are the masses and they're in grams. But if we are given the atomic number, but because we are dealing with numbers, we can just say the 37. And atomic number, which is Z, is equals to 17. Now, we are asked to find the number of neutron. Number of neutron, which is N, is given by, is going to be equals to what? Now, if we make the column for formula and the calculation, if we make a column for formula and the calculation, we are going to have the following, that we said that atomic mass, which is A, is equals to the atomic number, which is Z, plus the number of neutron, which is the N. Now, since we are having 37 is going equals to Z, which is equals to 17 plus N, now you can make N the subject of the formula, and you can find the answer, which is what? It's 20. Good. So you can make a conclusion now that the number of neutron of this particular atom, or of this particular isotope of chlorine, is 20. But for the charge of it, if we want to find the charge, grab here also. For a case of charge, the data which we are having here is that we are having the Z, because we say that the charge is going to be given, by the chemical, chemical property of this element, which is atomic number. And this we can now write that the charge, normally we denote it by capital letter Q, that is equals to ZE according to the formula we are having. And this E is constant, every one of us know it. And then you're going to take it, that is 17 times 1.6 times 10 power negative 19 coulomb. Remember, this is a constant, and we say it is electronic charge of this kind. Now, if you multiply this, you can now obtain the answer for this. But remember, I gave you the assignment, finalize it. But remember that the charge is going to be in coulomb. Make sure that this is in coulomb. Dear student, I think it has now come to a part of making sure now I gave you an exercise and be in position to write it. I think you have already prepared a place where to write it. Please try to do the questions which I'm going to display them here. do them properly, share with your fellows, and then once we meet, we'll be in a position to find out how far were you in this topic. I think that you have just enjoyed our period. We have just discussed all of these things which are very important into our life, and we are in a position now to know, you have already understand what is the structure of the nuclear. So I can say now that this is our end for today. I can say my name is Teacher Jafari. We are going to meet next period. Bye.
Let's study, be educated, elimu ni kazi. Elimu ni kazi. Let's study, be educated.